Hi, this is Roman, and today we're going to be going over Unit 7 on circles, Day 26, using radians, Part 2, with a focus question here of how can we use an equation to determine the length of the arc of a circle. So I'm going to be modeling questions in Jamboard. So here's my Jamboard. The first thing I want to address is how do we get this formula of arc length in radians? Or when we have something in radians, we're allowed to say the arc length is equal to the central angle times the radius. So I want to start with our current understanding of the arc length of a circle. And our current understanding is the arc length is a piece of the circumference of a circle. So we could say that the circumference of a circle is 2 pi r. And then to address that piece of the circle, we multiply this by the central angle, represented by theta, over 360 degrees, right? And we've been calling that our arc length. So now we want to create an equivalent expression here. And what we can do to convert it is multiply by 180 over pi. So let's do that. So we have theta over 360 times 2 pi r, and we're going to create an equivalent expression by converting this. So we're going to multiply by 180 over pi, and let's see what we could do. I see that we could divide out our pi's. And for now, what I'm going to do is I'm going to multiply 180 times 2 to get to 360. And I'll write the angle theta next to it, and we also have r. And we have all of that over 360. And we see that the 360's divide out, and that's how we get our arc length in radians. And in many textbooks, they use an S for arc length. So you'll see this formula circulating on the web, S equals theta r, S equals r theta. So now let's take a look at a question. And we're going to do a Regents question here. So in the diagram below, circle 1 has radius 4, and circle 2 has a radius of 6.5. Angle A intercepts an arc of length pi, and angle B intercepts an arc of length 13 pi over 8. Dominic thinks that angle A and B have the same radian measure. State whether Dominic is correct or not. Explain why. So the first thing we want to do here is use our formula, which coincides with our focus question here. So S equals r theta, or the arc length, right? Maybe we'll put that in parentheses here. Arc length. That's what we're doing. So the first thing I want to bring attention to is if we were using that degree equivalent expression, this gets very messy. But with the arc length formula, we could do this in a breeze. So let's label. Let's have our first circle. Let's call it circle 1. And I see one of my C's kind of look like an E there, so let's fix that. So circle 1. And we're going to say that circle 1 is equal to S equals r times theta. We're told our arc length is pi, and our radius is 4. And instead of theta, we're going to write angle A, because that's our central angle. And if we want to solve for A, we would just divide by 4 and say angle A is equal to pi over 4. Now let's take a look at circle 2, which I'm going to label in red here. We're going to use the same exact formula for circle 2. So we're going to say this is S equals r theta. And in this case, we have a arc length of 13 pi over 8 and a radius of 6.5. And our central angle here is angle B. So to get angle B by itself, I'm going to have to divide by 6.5, excuse me, on both sides. And this looks a little bit messy here. So what I'm going to do is I'm going to utilize my Desmo Scientific Calculator. So I'm just going to type in Desmo Scientific Calculator. And now I'm going to leave pi out of it because we always want our answers in terms of pi. So I'm not going to type in pi, but in parentheses, I am going to type in 13 over 8. And then I wanted to divide this by 6.5. Now I see my answer is 0.25, but I'm going to click this fraction bar right here, and it'll show my answer as a fraction, or 1/4. And I'll talk about why I chose to do that in a second. So now I've shown that if I rewrite this and I just put everything in parentheses and just put a pi next to it, which I'm allowed to do due to the commutative property, I could say that this is going to be equal to 1/4 times pi. Well, 1/4 times pi just simplifies to pi over 4, right? So now we can take a look at Dominic's statement. Dominic was saying angle A and B are the same radian measure. Well, we can make a statement now that we think Dominic is correct. Right, so let's make that statement together. Because I see angle B and angle A have the same measure. So we're going to say Dominic is correct. When we found the angles, using the formula S equals R theta for arc length, we found angle B and angle A were both pi over 4. Now we want to make sure that we understand the question here, right? Stating whether Dominic is correct or not, that is going to be either stating Dominic is correct in words like I did, or a simple yes or no. Yes, Dominic is correct, or no, Dominic is not correct. And then that keyword explain there, that signals that we're going to have to use words to explain our answer. So our justification here is not sufficient with respect to the question. We must use words to explain what we wrote there in terms of our algebra.